do right here is we're going to talk about area of a right triangle. So the one thing to keep in mind is the area of a triangle is 1/2 base times height. The perimeter of this is going to be the base plus the height plus the hypotenuse. Okay, and so when you're looking at these common measurements with a right triangle, you're just going to use either special properties or Pythagorean theorem or trig ratios to find the pieces that you need. Okay, so this first question right here off to the side is the easiest one. It's straightforward, and it comes like it's similar to what we've already seen, except now it's a right triangle instead of a non-right. And so your area formula is just 1/2 base times height, and count your pieces. So from 2 to 8 has a total base of 6, and from 1 to 5 has a total height of 4. And so you can simply type that in, 1/2 the base of 6, a height of 4. Remember, you can enter your answer as a calculation, and if you calculate that out, 1/2 of 6 is 3, 3 times 4 is 12, and you would get your measures. All right, I want you to see if you can answer this question right here, again, on your own. And can you use what you know about right triangles to find the area of this triangle? You have an isosceles triangle with equal sides of 13 and a base of 12. So try that one on your own. Right, determining how you're going to manage right triangles. If you have angle measures, you can use trig ratios. If you don't have angle measures but you have side lengths, you can use Pythagorean theorem. So in something like this, the altitude of an isosceles triangle does bisect the base, which means that each of these portions of the base are going to be 1/2 of 12 or 6. And so what you can find right here is if we took the area is 1/2 base times height. So 1/2, our base is 12. We already have that measure. What we don't have is this height. I'm going to call it h. But we can find height using Pythagorean theorem, right? So if we calculate our height, we have 6 squared plus h squared equals 13 squared in this right triangle right here. And so if we subtract 6 squared from both sides and then extract our root, here is our height, the square root of 13 squared minus 6 squared. And so again, if you just enter your answer as a calculation here, you'll get your decimal equivalent for that as well, but you can enter the calculation for your solution. All right, so try that with this remaining question. It's the same idea, except here you don't have to determine h, or determine that you need to find h. They already label it as x, and you can follow the same process. See if you can find both the perimeter and area of that triangle. In order to find both the perimeter and the area, you do need to know that missing side x, and so we can use, we're not given any angles, we're given the sides, so we can use Pythagorean theorem. So x squared plus 7 squared equals 12 squared. Subtract 7 squared from both sides and extract your root. So here is our value x. When you are solving this, the perimeter is going to be the sum of all sides, so 7 plus the 12 plus this whole calculated value of the square root of 12 squared minus 7 squared. So if you enter that as your calculation, you would get the decimal equivalent for that. And if you're finding the area is 1/2 base times height. The base we see is 7, so this is going to be 1/2 times 7 times, and this height is that square root of 12 squared minus 7 squared. So once again, we just plug in the calculated value for that, and it will give you your calculation for that as well. So these would be your calculations or the calculated values for those problems. All right, the final slide, I'm just again going to kind of talk through since we're running short on time. But these would be the sort of other types of concepts that you need to extend to find the area of these right triangles. Okay, and so the first is the special right triangles. So either common triples or 30, 60, 90, 45, 45, 90 triangles. And so here, if you know that your area is 1/2 base times height, If we have a 30, 60, 90, we know the side opposite 30 degrees is x. Hypotenuse is double that. And then the leg opposite 60 degrees is x root 3. We use the patterns here. So if the hypotenuse is 20, what does that mean the side opposite 30 degrees has to be? Half of 20, so 10. And once we know that that measure is 10, the leg opposite 60 degrees is 10 root 3, fits our pattern. And so our area is 1/2 the base of 10 root 3 times the height of 10. And so that would be our calculated, or our calculation. If we entered the calculated value as a decimal, that would be our solution. Okay, so that's one way, is to use the special properties. You may also be asked to use trig ratios to find these areas. So I'm going to go through this first one and have you try the second one if there's time. Okay, so here if we label what we have, A is 40, angle A is 39 degrees, and we want to find the area. Well, the area of this triangle is 1/2 base times height. We don't know what our base is, but we do know our height is 40. And we can find our base by using a trig ratio, right? With respect to this angle, we have opposite and our base is adjacent. So opposite and adjacent, which trig ratio relates opposite and adjacent? TOA. And so you know that the tangent of 39 degrees is equal to opposite 40 over adjacent B. Multiply both sides by B. To solve for our B value, we now divide by tangent of 39. And so here is our B value, 40 over the tangent of 39. And so if you enter this, remember if we are entering this as a calculation, we do need to turn 39 into radians. So 39 times pi over 180. If we entered that as the calculation, we would be good, or we can leave it in the calculator and just type it directly. The approximated value will be 987.92. And so either of those would work. And I'm just going to talk through the last one because we're about out of time. So here in this next example, we know that C is 24. A, again, has an angle measure, this time 36 degrees, and we want to find the area. So the area is 1/2 base times height. Now we don't know either of them, so we actually need to find both our A and our B values here. And so we are going to use trig ratios for each one. So to find our base, we have adjacent, with respect to the angle, we have adjacent hypotenuse. Adjacent and hypotenuse are related by which trig ratio? Cosine. So the cosine of 36 degrees is equal to adjacent over 24. So multiply by 24. So here is your base. So we get 1/2 times 24 times the cosine of 36 degrees. And if we find our corresponding height A, we have, with respect to our angle, opposite and hypotenuse. Opposite hypotenuse are related by sine. So the sine of 36 is equal to A over 24 multiplied by 24. Here's your A value. That goes right here, 24 times sine of 36 degrees. And so that would be your calculation. Turn it into radians, and that would be your answer.